Hello, everybody. Very excited to be here today and speak to you about testing. Yay! So I'm Carl. I work for a company called City Dev Labs. We are an agency. We do lots of different kinds of projects for various clients. And we have some Angular projects and some projects with the other framework and lots of interesting stuff. And you can find my contact details there if you want to follow me. And you can check our company website if you're interested. And first I'd like to begin with a little story. So once upon a time there was this developer, could also be like a team, but in this story it's going to be a developer. And he started working on a new application or a new project, and he was very excited to get started on a new framework, powerful framework such as Angular, for example. And he began working on the project, and he was very productive at first. He was kicking out features and the client was happy, and everything was good, life was good, and he was happy. And after a short amount of time, the client started asking some changes to the existing features, and well, the developer thought it's only natural. It means that people are using it and it's useful, and he was happy to do it. And he still had time to crank out new features also, and he was still happy. But a little bit after that, some bug reports started coming in, and he had to debug his software and spent more time with the problems than working on new stuffs. And a little bit more time went by, and soon he was swamped with debugging and problems, and he was getting really frustrated. He didn't have time to work on any new features at all, and just thought to himself, if there was any way that could make sure that all of this existing stuff keeps on working when I make changes. And you might recognize yourself in the past in situations like that. The moral of the story is kind of like the moment you start to need automated tests, it's already too late. So you should always think about them before it's too late. But let's talk about testing Angular. There's been some mentions about the Angular CLI already today, and yeah, it's awesome. Angular CLI for the win. You just generate your app with the CLI command. You generate some components with the CLI command, and what you get out of the box is unit testing framework, test runner Karma, Jasmine, and some Angular testing helpers, and you also get end-to-end testing with Protractor. And you don't have to touch that configuration at all. You just get everything ready. And how you actually run your tests, you just again use the CLI, write ng test and it runs your test, or you just write ng et and it runs your end-to-end test. So that's basically how you test your Angular apps. I'm pretty much done here, so maybe we get some beers now. What do you think? Okay, just kidding. I have some more stuff. But in all seriousness, 30-minute talk slot, it's kind of short, so we can't get too technical in this talk, but hopefully most of you will get something out of this. If there are people here that are not that familiar with testing, just a quick recap of what types of code the Jasmine framework gives you. So you define your describe test suite, and then you have a before each where you set up stuff, and then you have the actual test inside a function called it, and where you execute the code you want to test, and then you make some expectation or verification of the outcome. And these 3 steps is how you test code in all frameworks or all languages. It's always kind of like this 3-part process: set up, execute, and verify, or also known as the AAA: arrange, act, and assert. But before we go in and look some code, this is kind of like a high-level overview of example Angular applications, where we have some components, which are the red dots, and a few services that are the blue dots, and the lines are the dependencies between them. So we have like a few top-level components that have some dependencies on services, and they have some dependencies on some lower-level components. And how you test all of this together is with end-to-end tests. So what you get when you use the Angular CLI to generate your app, you get something like this as the starting point for your end-to-end tests. And the point of end-to-end tests is to execute your application similarly as a real user would use it. So we have this concept called a page object, as you can see here. And the point of the page object is to abstract all the DOM-related stuff and routing-related stuff outside, so that in your tests you can focus on the same stuff that the user would actually do, without having to go through all of the DOM selectors and stuff like that. I'm going to show a little bit more real-world example here. I have this example application called Angular XL, which is kind of like Excel done in Angular. And by looking at this end-to-end test, we can see what the application is supposed to be doing. So it should display a table of cells, as you may know if you ever used Excel. It should evaluate math expressions and display the results. It should allow referencing values from other cells. And there's some function calls that can be used with it. And as with the real Excel, it should re-evaluate expressions when the values change from other cells that are used in those expressions. And we can check what it looks like by running our end-to-end tests. Oh, actually I have it in headless mode right now, so we can't actually see it. I'll just comment this out so we can actually see it. And run it again. So here you can see how the end-to-end test executes our Excel application, and everything passes. Yay! Okay, so that's end-to-end testing. Let's move on and focus on this one component here in the middle. If we want to test only this component, when we use Angular CLI to generate a component, we get something like this. It's quite a handful, to be honest. And what it does is it uses those Angular testing helpers to configure a testing module for us, and it declares only this one component here, not anything else, only this one component, and then it creates an instance of that component, and then we can use it in our tests. But in real application, our component has some dependencies, as we can see here. It uses some other components, and it uses a service. So what happens if you have a component that has all of these dependencies and you run a test like this, you get errors because the testing module doesn't know anything about our services and other components and stuff like that. So what you can do is you can declare everything, provide everything, and if you have lots of tests, you can imagine that declaring all of these in every test can get quite tedious pretty soon. So what you can do is you can also just use your actual module and just import that, and everything will be there already. So you don't have to worry about declaring stuff everywhere. But what happens now is that instead of just testing that one component, we are actually testing all of these together. So it's actually an integration test. And if we do this kind of test for a high-level component, then it's getting pretty close to actual end-to-end test, since we got all of that stuff working there together, and you can access the DOM and do similar stuff as in end-to-end tests. So in integration tests, we usually want to get a little bit more isolated from all of this. And what you can use then is create a so-called shallow test by using a no errors schema. And what that means is that you don't have to declare all of those other components. When this component renders, it will not complain about unknown elements. It will just render whatever it comes out and not care what it is. And it also means that it won't actually execute those other components. So in this case, we get a little bit nicer integration test where we test only this component, but we are still using this real service here. And if we look at another example here, we have this Excel component. It's a pretty simple component. It doesn't have any logic in the component class. It just renders some cells. So if we wanted to test this component, this shallow test would be a good fit here, and then we can get a handle on the actual DOM element and make assertions on that so that we can see that it renders right amount of stuff. Okay. So next step would be to isolate this even more by providing a mock service. This way we can test only this component without any other dependencies. And we can use this value provider. We just create a mock object and tell Angular testing module that, okay, instead of creating an instance of this service, just use this value here that I'm providing. And this way we finally get like really isolated test for this one component that we can, it would now be called unit test, only testing this one unit in isolation. But we can still go deeper. We can split this component in two parts and think about the template and the actual component class separately. And actually the dependencies to the other components are on the template side, and then the dependency to the service is on the component class side. And what we can do is we can get rid of all Angular related stuff altogether, because the component, it's just a plain old JavaScript class. We can create a new instance of it by ourselves without any Angular testing modules at all. And we can provide our mock service to it with dependency injection. The one thing that you have to keep in mind in this case is that you have to call the lifecycle hooks manually, because of course when we don't have any Angular running, Angular can't do it for us. And in my experience, I like to write my components so that most of the actual logic is inside the component class, and keep the logic out of the templates as much as possible, so that I can write tests like these that don't need to test the template side at all, and I still can be confident that it works by just testing the logic in the component class. And we can take a look at the example here. So this is a test for the cell component in our Excel app. The cell component has a very simple template, only one input element and then an output of the values. And most of the stuff is happening here inside our component class. Don't need to go too deep in that now. It's using observables from the actual input element and combining it with an observable that we get from the service that knows about all of the values in the other cells. But in this, we can see that we just create a new cell component by ourselves here without any Angular, and then we can call methods on it, and we can access its public properties, and then we can write our tests this way. Here we can see that it should evaluate values with the spreadsheet service and stuff like that. And we can also run it. Yay. As we can see, 26 tests successfully executed. As I said, there's not that much time to go really technical in this 30-minute talk. So if you want to learn more about this example app or come talk to me later, I can show you or just discuss testing related stuff. I'm at the office hours afterwards. But so these are finally, so in the final test was we get isolated unit test for only the component class, even without the template. So these are the types of tests that we have discussed here today. And how are they different? Well, unit tests are usually fast. End-to-end tests not so fast, and integration tests are somewhere in between, depending on how you write them. And unit tests usually are more reliable. End-to-end tests tend to be a little bit more brittle, especially the DOM changes. Abstracting the DOM to the page objects helps a little bit with that, but still you might get more false alarms or stuff like that. And unit tests are running in isolation, and end-to-end tests are not. They execute everything, and integration tests are again somewhere in between. But then again, if you only write unit tests, you don't simulate any real use, so you don't really have any confidence if your components are working correctly when combined together. So end-to-end tests provide the actual feedback that everything is working together as expected, and again, integration tests are somewhere in between. So how do you know what types of tests you should write? You need to ask yourself, why do you write tests? Any suggestions? Well, usually it boils down to these 5 different reasons or factors. You want to verify the correctness of your code, it's working correctly. You want to prevent regressions when you make changes. You want some support for refactoring. You get more confidence in refactoring when you have a good test suite. You might want some design aid, especially in the beginning, and also documentation. So these 5 factors are usually the reasons why you might want to write tests. And all of those different types of tests don't provide all of these benefits. And some factors are more important in different parts of your applications, and some others are more important in other parts of your application. For example, like unit tests they offer better design aid, and integration tests provide better support for refactoring, and end-to-end tests verify the correctness from the user point of view, and stuff like that. And you can't just pick all of them, and you can't just pick one of them. It's always kind of like striking a balance between these things. Also, your focus might shift during the life cycle of your project. So in the beginning, you might be first more focused on verifying the correctness of your code and getting design aid. But then later on, you might be more focused on shift your focus on supporting refactoring and preventing regressions. So you really need to think about these things, and if you work in a team, you should discuss these things in your team so that you get the best return on the investment of actually writing the tests. Because if you don't get any value out of the test, there's no point in writing them. And if you have a neckbeard hacker coworker that just writes in your pull request that you should write unit tests for this because it's industry best practice, well, that's not a very good reason to write tests. It's still a valid reason, yes, but it's not a very good reason, because there's still a lot of dogma related to testing, so you shouldn't get stuck on the dogma. There are all these best practices, and all these famous people are telling that you should write these types of tests, or some famous Ruby guy tells that TDD is dead, and then some other guy tells that you're not a real programmer if you don't do TDD, and or you should have this there's this testing triangle that says that you should have this amount of end-to-end tests and this amount of unit tests and stuff like that. But all that kind of like dogma, or it's inflexible. So, but testing needs flexibility, and testing needs creativity. So don't get stuck on that. Just think that an imperfect test today is better than a perfect test someday. Like even if you are just a beginner in testing or more experienced, you should just write the best test you can today. You can always change it later or even get rid of it. You shouldn't be afraid to delete tests when you don't get value out of them anymore. If your focus shifts from between those 5 factors, you might want to get rid of some tests that you have had earlier. Just and also an ugly test is better than no test. In real-world applications, sometimes we are in a hurry. We might be working on a deadline or something like that, and the code might be a little bit ugly, and then the test might be a little bit ugly. But you shouldn't be afraid to write test for ugly code, because ugly code needs testing the most. And especially since the problem with quick and dirty is that the dirty remains long after the quick has been forgotten. So that kind of code needs the tests the most, and you should really write the best test you can today and get started with writing tests and get kind of feeling of what kind of benefits you get from different types of tests, and see what works for you and your project. Okay, that's it. If there's time, I can show a little bit more about those actual real-world examples, but do you have any questions? Or you can come see me later in the office hours, but yeah.
How would you test an observable?
Good question. There are different ways to do it. Depending on kind of what level you are, I can show a little bit in this, because in this component we actually have observables coming in and going out. And in this case, I'm using this Angular testing helper called fake async, which helps in testing async code, which observables are. And if we take a look at this component, for example, this we have this formula, which is the actual the input element in the template, and we get the value changes from that input. We have a debounce of 400 milliseconds and also distinct under change, and then we combine it with stuff coming from the service, and what we get out is the value. So it will evaluate when we change the input, or also when other cells update from the service. And in this case, we can use this form control to give a value, and then we can use this. Tick is also Angular testing helper that we can use to skip over the debounce. This is just a variable here that is bigger than the 400 millisecond debounce time, and then we can see that our service gets called with the value from the observable of the formula. There's also a very interesting kind of test that you can write for observables, which is called marble testing. Marble's diagram is the way that you can kind of like create a diagram of the values over time to visualize the streams. And you can actually use those to test them also. Here I have this helper called Jasmine marbles, and that allows me to write kind of like this provider this way that I can give those values in a timeline, and then I can have this expectation of what's the outcome in another timeline, and then it will, and then I can use this expect to be observable to kind of like verify if I give it this kind of observable, I expect this kind of observable to come out. So this is kind of like an interesting way. This is a little bit, it's not good for every type of test. It's a little bit more involved, and it's not that easy to set up and stuff like that. So most of the time you can just do it with the normal async helpers. But I think we are time here, so if you want to discuss this more, come see me later.
Thank you so much, Carl. Now give him a round of applause.